So, hi, my name is Matt. I'm with Digium. I'm the head of the Asterisk Development Team at Digium. So today we're just going to be looking at what went on in the past year. What have we done for Asterisk 12? What's an overview of the technology in the next release of Asterisk? And more importantly, what does it mean for all of you sitting in the room? Before I get going, has anybody actually attended Mark and Josh's talk on the new SIP stack? Few people. Excellent. Very cool. Did anybody attend Jared and David's talk on the new interface, ARI? All right, some more people. So now we get interesting. Did anybody not attend either one of those talks? All right, so this is not just a complete rehash for everybody in the room. There is actually some people who have not heard of either one of those things, so that's good. All right, so what happened last year? Asterisk 11, great success. We had a wonderful time making that product. It is a long-term support release, which means that the Asterisk development team will do bug fixes on it for 4 years, followed by security fixes for an additional year. The major focus in Asterisk 11, being an LTS, was on end usability. It was on user features, interesting new things that you can do in the dial plan, making sure that we had robust and stable documentation for AMI events. But we also had some really cool new things, and this being, of course, the WebRTC and integration track. I've got to at least make sure I've mentioned WebRTC one time. Asterisk 11 did contain the initial support for WebRTC, just as Moises actually just went over on how you actually can configure Asterisk in Asterisk 11 to be a WebRTC gateway. So it had a whole bunch of very cool things going on in it, but the real focus of Asterisk 11 was to provide everybody a stable platform for them to go run Asterisk for their business. It's a great long-term support release. At the same time, during the Astra DevCon last year, we had a lot of discussion about the kinds of things we would like to do in Asterisk. And there's a number of architectural issues in Asterisk that, as a developer community, we felt it was appropriate and the right time to go start addressing those things. Now, how many in the room are aware of how the Asterisk project does its releases? Okay, some people know, some people don't want to admit it. That's okay. So there's 2 types of releases in Asterisk. We have the LTS releases, which are the long-term support, and we have standard releases. And we alternate between the two. So last year was an LTS release. This year, Asterisk 12 is a standard release. Standard releases are our time as a project to go address these kinds of architectural things. They receive bug fixes for 1 year. They receive security fixes for a year after that. But after that, we don't continue to support it. And the purpose of the standard releases is to do the heavy lifting to prepare for the next LTS. For you as a user of Asterisk, it's the time for you to actually look at what is going to become the next generation of the product, to begin doing the kinds of engineering things that you want to do in order to take advantage of what is the next LTS. So Asterisk 12 is a standard release, and as such, it contains a lot of really cool new things. We did some major heavy lifting in improving the core architecture, but in particular, the developer community last year wanted to focus on 2 main areas. We wanted to focus on the SIP functionality in Asterisk, and we wanted to focus on the APIs in Asterisk. So who here was at AstraCon last year? So I'm just going to keep asking questions to make everybody raise their hands constantly. Do you guys remember the wrap-up talk from last year? No? Nobody? Good. Then I can just lie my entire way through this, right? And just like, yes, this was actually announced at the wrap-up talk. It was. So at the end of the wrap-up talk last year, we said, we had a great DevCon. It was an excellent time. And the 2 things we're going to focus on are SIP and APIs. And hey, we actually did it, right? We're here, and I'm telling you right now, we actually set out a goal last year of what we wanted to do as a community, and I think we succeeded admirably in making Asterisk 12 address those 2 things. Okay, so if we already have a SIP channel driver, why do we need a new one? I can connect a SIP device to Asterisk. It works, right? Okay. So the existing SIP channel in Asterisk was added to Asterisk in roughly 2002, and that's the best approximation I have by looking at the very vague subversion logs at that time frame. And it has grown a lot over time, and SIP has grown over time. Whenever anybody says, well, I have a SIP device, well, what do you really mean by that, right? There's the core SIP RFC, but there's hundreds of other RFCs at this point in time that have further defined what it means to be a SIP device. And the initial design of the SIP channel driver and Asterisk was really just to go make that basic SIP functionality work. You know, not having a crystal ball, Mark didn't actually foresee the fact that this was going to explode to the entire world and everybody would be producing SIP devices, right? So the initial design wasn't able to really accommodate this future growth. And we've been working with it over time, but for a long time there has been a desire within the community to go address the architecture of Chan SIP to be able to add more SIP functionality. So this is the design of the SIP channel driver in Asterisk prior to Asterisk 12. You have the Asterisk core, you have a channel driver, and I've got a little phone beneath it that does things. And that's the best phone clip art I could find that I could get over for fair use. So this is the SIP functionality in Asterisk 12. So as you can see, what we've done, and for everybody who's a developer in the room, you're probably wincing at this you know, slightly bubbly looking thing. But what I'm trying to highlight here is that what we've done in Asterisk 12 is break up the SIP functionality into core components. All of these components, and even some of these large ones like registration or media or publish and subscribe, are actually multiple loadable modules in Asterisk that provide different functionality. If you don't need that functionality, you don't have to load it. If you want to extend that functionality, you can write that functionality in a separate module. What that means is that it's much easier for anybody to go add more functionality to the SIP, to what would be normally called the SIP channel driver in Asterisk. What we've also done is we've actually used a very well-known, very widely deployed SIP stack called PJ SIP, produced by Telu, and that is actually providing the actual SIP technology in Asterisk today. We're very excited about what this architecture and being able to actually split things up provides us. For example, we actually have a single module in Asterisk that just adds reason header support. That's all it does. If you don't need reason header support, you don't have to load it. If you want it, you can add it in. This allows businesses who would previously have to patch Chan SIP to be able to put their specific logic into other modules and makes it much more easy to maintain that SIP logic. So, yes, the SIP stack of the future is now. It's here. It's in Asterisk 12. We have feature support for just about every single feature that was also in Chan SIP. There's a few things that didn't make it, but we fully expect to get those in short order as well. This also comes with new features, which is just sort of a result of actually moving to a more modern architecture for our SIP functionality. Some of the cool ones, multiple registrations to an endpoint. That basically means that if I have a cell phone, I have my soft client, my WebRTC client, sure, I'll mention WebRTC again, and I have a desk phone, they can all register to a single quote-unquote endpoint in the new SIP stack. If you call it, it will call all of those devices. You can also call each one individually. And because they're all registered together, it treats them all as being essentially your endpoint. It's also multi-threaded. This is a huge improvement over the previous architecture. If I have to go out and hit a database because I'm running real time, that's not going to block or slow down any other requests that are currently going on in the system. If I have to go resolve DNS, that the resolution of a domain name does not impact any of the other SIP requests that are being sent to Asterisk. So that's a huge, huge improvement over the previous Chan SIP. Unlike Chan SIP, it's not just configurable. I can extend the SIP functionality. I can add my own modules. I don't have to, if I want to add a channel variable that gets set when a particular request comes in, I don't have to go hack it or configure it or set an option to go do that. It can live in its own separate module. Most importantly, though, we need you, as in the community, to help us test it. We need people to actually go deploy it and verify that it works with various ITSPs and various soft phones and various other phones. We've done a lot of testing ourselves, but we're under no illusions that this is, a completely done thing. It's a done deal. We fully expect that we will have to do more work to improve the interoperability of the new SIP stack. So I highly encourage everybody to go give Asterisk 12 a try, go use the new SIP stack, and so that we can improve it and make sure that it is the path forward for Asterisk. Okay, so that was goal number 1 that we set out for last year. Goal number 2, APIs and Asterisk. Really, when we talk about APIs and Asterisk, Asterisk today has AMI and AGI, right? The Asterisk Manager interface, the Asterisk Gateway interface. AMI, call control, right? I want to know what's going on in the system. I want to move channels around. AGI, I want to control a channel, but I don't want to do it in the dial plan. I want to have an external script that controls the channel. Great. That's what they do, and they're really good at doing that. Unfortunately, the APIs in Asterisk today have a tendency to expose some of the internal implementation details in the core. So how many of you are familiar with zombie channels in Asterisk? Hey, that's pretty good. All right. So you guys are going to love this part. All right, so what is a zombie channel? Zombie channels happen when a strange operation in Asterisk called a masquerade occurs. What is a masquerade? That's hard to answer. A masquerade is essentially us trying to steal control of a channel in Asterisk to tell it to go do something else. The channel gets renamed. You end up with a zombie channel that was the channel. And now, if you're building a system on top of Asterisk through AMI, you have to maintain all of that state. Probably even the more tricky part of a masquerade is it's not even always easy to say when a masquerade is going to occur. We know, right? We wrote the system. We're developers. If we actually tried to write out every single time a masquerade occurs, I'd have 30 bullet points with a whole lot of special clauses that says things like, well, if it's Tuesday and it's raining and you redirect it, then you won't get it. But otherwise, you will. But really, all of these things about renaming the channels and masquerades and all this stuff is really just a symptom of a larger problem. And that problem is Asterisk is exposing too much of its internal implementation to the user. What does anybody really care if we do a masquerade? Why should you even know about it? You don't want to have to know about it. You just want to know what the channel's doing. But you don't care what goes on inside. So our goal for the APIs was to facilitate the existing APIs as well as to help us go build better ones. So we knew we were going to have to do a lot of core changes to do this. There was no way around the fact that in order for us to solve the zombie channel problem, in order for us to solve the renaming problem, to allow people to use Asterisk as an engine that powers their business, we had to go do some heavy lifting. Again, as I reminded, standard release. That's why we're going to do it then instead as opposed to an LTS. We have to go do these architectural changes to go do this. All right, so the first step in this, in killing the masquerades, was to go use a different bridging framework. So way back in the misty days of Asterisk 1.6, Joshua Culp actually added a bridging framework to Asterisk. And it wasn't until Asterisk 10 that we actually began to make use of it. So the bridging framework actually is already used in Asterisk, but it's only used by ConfBridge. So how many people have used ConfBridge in Asterisk 10 or Asterisk 11? Hey, that's good, good. Please stop using MeetMe. You can ask me more why later. But ConfBridge used the bridging framework. We knew that it could do the job. We knew that it can act as a bridge between channels and be efficient and be performant. The really great part about that is using the bridging framework lets us go kill the masquerade. So what do we have to do to go apply the bridging framework? And why is it a thing? Well, so in previous versions of Asterisk, being in a bridge, for two channels to be in a bridge, is really just a state. There's no object that is the bridge. Channels are just happen to be talking to each other. That's why we have to use a masquerade in order to steal it, because there's a single thread that is servicing both of those channels. In the new bridging model, we actually have an object that can maintain that state, which means it can actually help us move the channels around in the system. That means we also have to have a different threading model, though, than the existing one, which is really that every channel does have its own thread. Okay, so everybody's like, oh, geez, he's talking about channels and threads and threading models, and why do I care about this? All right, so for everybody who is, again, having to deal with zombie channels and things like that, hold your breath a little bit, because I'm going to try to actually show what happens during an attended transfer in previous versions of Asterisk. So for everybody who has never had to deal with a zombie channel, this is why we have this problem. So I've got Alice, and Alice is talking to Bob. That's great. And let's say Bob wants to perform an attended transfer to Charlie. Okay, well, there's Charlie. He's got his phone. He's ready to go. So we've got to somehow pull Bob away from Alice because he wants to go consult with Charlie about what's going on. Well, to do that, we have to actually yank the channel and steal it using a masquerade. So today, that means now you have a zombie channel, and the name changes. And you would think at that point that the Bob device is gone because you have this zombie thing, but not really. Bob's still there. He's still talking. He's still executing dial plan. But now he's doing it on Bob 3. So your system who's building on top of Asterisk has to know that SIP-Bob 3 and SIP-Bob 2 zombie are actually still the path of communication back to Bob. It's a lot of work for an external system. So then Bob and Charlie talk. They're talking, everything's fine. And then, all right, we're going to complete the attended transfer. Great. All right, so to do that, though, now we have to steal Charlie away from Bob. Hey, we have another zombie. More zombies. And finally, we have Charlie 5. But we have to know that Charlie 4 zombie, and Charlie 5 are all still really just Charlie, right? What is a channel? A channel is a path of communication between Asterisk and a device. We don't want to rename it. We don't want to have zombie channels. This is just, it's sad. So, all right, what does it look like today? And hey, look, we're using PJ-SIP as the channel. So, today we actually have a bridge that sits between the channels. This is, I mean, yes, by the way, that's all it was, right? We just made a big circle in Asterisk. This was a blob, and that's all the code that had to be done for that. This seems very trivial, but at the same time, it's very important because this opens up all sorts of new possibilities. Because we have a bridge that maintains the state of what is happening between Alice and Bob, this means that we can actually allow the bridge to relinquish the channel. So when we want to go do an attended transfer, we just pull the channel out of the bridge. The name doesn't change. It's still Bob. You're still talking. So if you're building a system on top of AMI, it's just Bob, and you just know that the path of communication is continuing. When Bob talks to Charlie, we just make a new bridge. And that bridge manages the communication between Bob and Charlie. Now, this lets us do some really cool things. So the first thing we can do is we can just do what we do today. We can complete the attended transfer. So when we complete the attended transfer, we just move Charlie into the bridge with Alice, and they talk. Bridges do the manipulation of actually moving the channels around safely. None of them get hurt in the process. But we can also do a lot of really other cool things because we have a framework now to help us with the bridging. So one of the things we can do is we can toggle. So Bob can talk to Charlie, and let's say Bob says, maybe Charlie's tier 3 support, right? Bob's poor tier 2, or maybe even tier 1. And so Bob is going to try to actually have Alice talk to Charlie, and he's like, look, Alice has a problem. There's all these things going on. Charlie says, you clearly don't have enough information ready yet for me to talk to Alice. Why don't you go back and ask her? So we can. Bob can just hit a DTMF key and go back into the bridge and say, you know, Alice, we need to ask a few more questions before I transfer you up to tier 3. And they can just keep going back and forth. Bob can keep doing it until finally you decide to accept the attended transfer. We can do some other really cool things. Bob and Charlie are talking. Bob says Alice has a problem. Charlie says, you know, this is probably better if we all just get in the bridge together and talk it out. So we can. Everybody can just join into an ad hoc multi-party bridge. So bridges are smart. They make use of the best mixing technology available. As channels join a bridge, they may start off in a native bridge where the RTP, if it's SIP channels, are directly going back and forth between the devices. But they can also be changed as the conditions in Asterisk change. If you do an ad hoc multi-party bridge, it'll change out the mixing technology to a soft mix mixing technology, the same mixing technology currently used by ConfBridge. You can also have dedicated mixing technologies. So there's one in existence today called holding, which essentially creates a very thin parking kind of application. So a holding bridge is, I have multiple people in the same bridge, but they're all just being entertained with some music or file or sounds or any other things that you want to choose as your entertainment. Now, they can't talk to each other, but I can also do things like have announcers join and have their media go directly to all of the participants. And all of this thing is being put together by this very nice cohesive framework. Bridges also have class. So anybody who's an object-oriented guy probably chuckles a little bit, but that's okay. So bridges can actually have metadata associated with them, right? And what this means is that in Asterisk, finally, channels are channels. They're the path of communication between Asterisk and the device. And bridges are bridges, and the two aren't trying to commingle. And that's a very important thing because that lets us do really cool stuff in the core. And finally, it lets us kill the masquerade. So people who are building systems on top of Asterisk will no longer have to deal with that internal implementation detail. All right, so one of the things we did in Asterisk 12 was go make use of this architecture. So not only is it used for all calls, it's used by all features in Asterisk. So all of the one-touch parking and one-touch blind transfers and intent transfers and recording and everything else is making use of the bridging framework. Parking has been pulled over to the bridging framework, as has agents, including Chan Agent. We'll get to Chan Agent in just a second. So parking makes use of the holding bridge that we were talking about. That also means that there's actually a new application called Bridge Wait that is available in the dial plan, so that you can really kind of construct your own holding bridges if you want to. Parking is also no longer dependent upon dial plan generation. It will still generate the dial plan kinds of things that it needs to if you want it to, but you can also construct your own parking logic using the existing dial plan applications. Agents. Anybody use Chan Agent? I'm sorry. We killed it. So for anybody, has anybody ever tried to use Chan Agent? Let's ask that question. Okay, so Chan Agent is dead. It's dead because the implementation relied on some of those masquerade-y kinds of things. But agents still live on. So the use case of agents are still met, but now it's met using the bridging framework. And there are simple dial plan applications, agent login, agent request, that let you construct an agent holding pool. So I can have a SIP channel call in, and he calls in as an agent, and he gets put into a pool, and he's entertained while he's waiting. Then something else comes and says, I would like to request this channel, and it pulls it out of the pool, and they talk using the bridging framework. And when the call is ended, the agent goes back into the pool where they continue to be entertained. And the bridging framework lets us do all of this without having to do any strange perturbations of the actual channel itself. So let's just bridge everything. It's great, right? Well, unfortunately, it isn't always that simple because there's one small problem that we also had to address. So lots of things were in the old bridging code. AMI was in the old bridging code. CEL was in the old bridging code. CDRs were in the old bridging code. And once we move to the bridging framework, we have two options. We either have to reproduce all of that code in the bridging framework, which is really not a good idea, or we have to find some way for these subsystems to be notified of what is going on in the bridges. So the goal here is to decouple the consumers of state, AMI, CL, CDRs, from the producers. And that lets us not only insulate these subsystems from changes in bridging, but also allows us to improve consistency in those different things. We need a way to communicate the state in Asterisk. That is called Stasis. So Stasis is a new internal message bus inside Asterisk. This is an implementation detail, but this is going to be important for the new APIs that we're going to be talking about in just a second. So this message bus lets us it's a pub sub message bus that lets us inform all of the various components inside Asterisk about what is occurring, both inside bridges, but also inside channels, about device state, and all sorts of other things. This means that the code for, well, let me go back here for a second. So messages. So messages are essentially taken from two different sources in Stasis. It's the events that would normally be transmitted over AMI. That actually now is going over the Stasis message bus, as well as it makes use of an old event subsystem that was also in Asterisk. And the way we've done this, we can actually publish inside Asterisk what we would call primary communications objects, as well as arbitrary data encoded in JSON, which means it's very flexible for additional messages and additional producers and consumers to be added and to use Stasis as a means of communication. But this is really the important part. This lets us decouple all of the consumers of state from where things were previously producing it. So the CDR code in Asterisk now lives in CDR. CL code lives in CEL. AMI code lives in Manager. It doesn't have to go live all sprinkled all over the place through bridging, through channels, and all the other places. So, all right. We have bridging, we have Stasis. That gives us the core architecture we need to go address the API problems that the community wanted to address. So it's easy to add additional functionality because, again, we can always add more things to Stasis and publish more things and consume state. Just as a kind of an example of this, as a proof of concept, David Lee actually wrote a RESTstats-D or a StatsD server integration with it. And it was just a proof of concept, but it exists completely as a separate resource module and publishes everything going on with every channel to a statsd server. Never had to touch a single line of code in channel.c or any of the channel drivers, but it knows exactly what's going on with all of the channels in Asterisk. That's the kind of power that this core gives us. It lets us actually not have to go change the Asterisk core, but still let us go integrate with additional systems. All right, we also get out of this a whole lot of improvements to AMI. Events are now significantly more consistent, but more importantly, events and the things that it's telling you has a very well-defined lifetime. A channel is always created via a new channel event. It's always destroyed via a hang-up. And there's nothing that changes about a channel, but you know it's still up and it's still working until you get that hang-up. With bridges, because they're now an object, we have a bridge creation and we have bridge destruction. So we know the lifetime of the path of communication between all participants in Asterisk, and there's never any confusion about what that is. But what else can we say about APIs? So remember, we have AMI, call control, system inspection. We have AGI, channel control, remote dial plan execution. That's great. And together they're very powerful, but it can still be hard sometimes to use them together. And the real reason why it can really be hard sometimes to go use them to build out a communications system is because the raw communication primitives inside Asterisk are still hidden from you from those interfaces, right? You don't actually have control of a channel. You don't actually have the channel object itself. You don't have the media itself. You have to go ask the dial plan to go do the thing that you want to do on the channel. So when we look at dial plan applications today, they're C modules. So you have queue, voicemail, large C modules that get plugged into the dial plan that you go execute. And you say to the channel, please go join this queue, and it disappears for a very long time into the queue as the C module goes and controls it. They're very configurable, which is great, but it still usually contains an element of embedded business logic. If I want to go change one of the IVRs in voicemail, I have to go into the C module and change the prompt that is actually being played, or I have to remove the code that's in there. So I have to be a C developer, have some knowledge of C to be able to do that. And applications are actually great. It's wonderful. I can just roll out some dial plan code and I've got a functional PBX. But we'd like to give the power that are in the applications to everybody. We want everybody, regardless of whether or not they're a C programmer, to be able to build their own queue, to be able to build their own voicemail subsystem. That's ARI. That's the new interface. ARI is not AMI. It's not AGI. Those interfaces are good at what they do. ARI is build your own communications application. You don't use ARI to call queue. You use ARI to build your own queue. And it does that by exposing the raw communications objects through a RESTful interface. If it uses a WebSocket to convey state back to you as events encoded in JSON. So what does something look like? So this is one of the really great things about ARI. It's a very approachable interface. So without even being a Asterisk expert, right, I can look at the call to the REST interface and say, I have a channels resource. All right, I'm dealing with something called a channel. And it's channel 12345. And oh, hey, I'm dialing Alice, and I'm going to time out in 15 seconds. It's a very, very approachable interface that can be easily wrapped up in any language of your choice. You can use Python, JavaScript, Ruby, Perl to go call this particular post and actually do a dial to a channel. You can also do media, right? So I can tell it, go play TT Monkeys. I want to hear Howler Monkeys on this channel. And I want German Howler Monkeys. One of the really cool things about this, too, is that what this operation will actually give you back is a handle to the media operation. It says, OK, I'm playing German Howler Monkeys back to this channel. What do you want me to do with it? And you have asynchronous control over that media. You can restart the Howler Monkeys. You can pause the Howler Monkeys. You can fast forward and rewind the Howler Monkeys. And through your application, you have control over the experience of that channel. All right. So ARI is an awesome technology. We love it. We'll be talking about it a lot. You'll probably hear more about it before the end of the day. It's a very adoptable interface. It's a very approachable interface. You don't have to go look at the source code to go figure out what the AMI events are. They're all documented, already up on the wiki today, and it's all JSON. It's not strange key value pairs that don't have any relation to each other. But technology is cool, but as Phil was talking about today, it's not just the technology, it's the applications. It's what you can go build with it, right? So I'll do my Steve Ballmer impression here of developers, 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 right? So the great thing about the REST interface, about ARI, is the fact that REST is a common paradigm for interfaces. It's something that every single developer who's a JavaScript developer, all 10 to 20 million JavaScript developers are familiar with REST interfaces. This is the right way for people to approach Asterisk. We want them to approach it from a comfortable position for things that they're familiar with. So we're very excited about what ARI gives developers and what they can go build. All right, so just to recap, and I'm just slightly over, so I apologize for that. I'm impeding everybody's lunch. What were the goals for Asterisk 12, the community set out? Do something about the SIP functionality in Asterisk, improve the APIs. And we succeeded. We have a new SIP stack in Asterisk. We're very powerful. It's very powerful. We're very, very proud of what it actually provides people who need SIP functionality in Asterisk. We have a new core. It wasn't a goal, but that new core allowed us to improve the existing APIs. It allowed us to actually define the lifetime of channels and bridges and all the other kinds of things that people have to consume in AMI. It also let us build out new APIs. ARI was not really possible without this core. And that is going to be very exciting for everybody who's approaching Asterisk for the first time, but it's also very exciting for everybody who's ever used Asterisk and integrated it into their business. But the best part is, it's still Asterisk. And all the cool things that Asterisk has been over the years, it still has all that. And that's what actually makes this powerful, is that yes, you have a new API, but you still have all the power of Asterisk and all the flexibility of Asterisk that it's always provided. Exactly. Thank you.
So even though we're slightly over, and because Matt Jordan here runs on, what, sunshine and rainbows, and you don't really eat food?
Unicorns and puppies.
Yep. We're going to take as many questions as you've got until he gives up and says, Uncle. So first question's right back here. Sorry, we will come right back to you. His hand was up a split second before yours. Just 1 minute. Let me get a microphone to you so everyone can hear you.
What's the prescribed way to get notifications when sort of submitting requests to ARI? Would that still be AMI to some extent, or it should be completely replaced?
So I'm going to repeat the question because I think I heard it correctly. What's the right way to get events with when using ARI? Okay. So ARI has a WebSocket connection that will give you the events encoded in JSON. Those events, however, are not all of the events in the system. They're events for channels that have joined your application. So you don't get the whole state of the system when you're developing an ARI application. You only get what you care about. Now you can go get more information. You can actually subscribe for all the channels and the bridges and the endpoints in the system through ARI if you want to, but you don't have to. You only have to look at the amount of data that you actually care about when you're writing your application. So if I'm writing a replacement for AppQ, use the WebSocket with ARI, get the events back through that, encoded in JSON. If I want to know the whole system today, and this is just today because there's still a future to go through, you would still use AMI. Yeah,
all right,
we'll go.
Just 1 minute. Let me get it over. Alistair, we will come back to you next.
So the usual question of channel IDs. I was noticing that the channel post action does not return the channel ID.
We have an issue to fix that.
Oh, good. Can you actually specify a channel ID when originating, or do you just get the channel ID back when the originate starts?
Today it would be you would get the channel ID back when it starts because there's a little bit of a race kind of condition there in terms of if the user specified the actual identifier for the channel, it may already be taken by the time they actually do the post. So Asterisk still needs to actually provide back the handle, but we fully plan on actually having an originate pass back you originated a channel, and this is what we created for you.
That will happen at the underlying level, to just not only in ARI, but also at the bus level, right? If we were to use some other interface. So
yes.
original will return the ID of the channel.
Yeah, so technically, actually, the underlying C code that already does an originate, AST-PBX outgoing extend /app, does have that ability in it. We just have to go make use of it in ARI currently.
So an eventual other module, not ARI, could just use that.
Correct.
Right away. Thank you.
Yep.
Candy for you.
Did I hear that if you have multiple registrations, you can place a call to just one of those? How do you specify that?
Today, there is a function, PJSIP dial contact, I believe. I can't remember the exact name for that, but that lets you actually specify, if you want to go to that level, the specific AOR, the specific contact on the AOR that you want to go contact. Correct.
All right, next question.
Hi, can the output of a bridge be considered like a channel so you can have nested bridges so you can do things like agent coaching? If that makes sense.
You can, actually. So one way you can build sort of a nested hierarchy of bridges is actually by using local channels to tie them together. And if you don't, the bridges actually can also be merged if the local channel is optimized. So if you use local channels without optimization, you can construct a hierarchy of bridges so that you actually have like a master bridge that is receiving media from all of the lower bridges. And then you can actually create, just kind of keep going with that whole concept. We actually did do some interesting tests with local channels and bridges. And this is probably going to scare people, but you can actually transfer whole bridges now. Right, so theoretically, you can actually have, if you have an ad hoc multi-party bridge, it is possible for that entire bridge to be transferred to the dial plan and have it go execute by virtue of a local channel. So you can actually put everybody into parking, which is kind of funny.
All right, Alistair has another question because he wants more candy.
For the holding mixer technology, in the default configuration, is that a separate bridge for each holding party, or is there by default a global one that everyone's in?
If I recall correctly, the way, and we actually debated a lot about the implementation of that, what we ended up choosing was when you join a holding bridge, you have a couple options. You can either not specify anything, in which case everybody goes into a global holder one, or you can also specify a specific holding bridge that you want to go join, in which case you can actually compartmentalize them into different sub-bridges. Now, the fact that it's a holding bridge means for the most part, they have no knowledge of where they are. They're just getting, lovely music piped to them. The nice thing about that, though, is that the reason why we ended up doing separate holding bridges is because you also have announcer channels. And an announcer channel can join a holding bridge and say, your call is important to us. You've been waiting for 5 minutes, 30 minutes. Please don't hang up. So having that different compartments ended up being very useful for that particular use case.
All right, we've got another question. Just a moment, I'll be over. First, your candy. Oh, thanks. Now your question.
So, a WebRTC question.
Yes.
I think I saw a pull request out there for a VP8 codec. Is there what's going on with video codecs?
So today in Asterisk, we still don't have the ability, and it's a very good point to debate whether or not we ever want the ability to transcode video, right? So Lorenzo, however, who's a great community member, actually did provide a patch for Asterisk 12. So in Asterisk 12 today, we do have pass-through support, however, for VP8 as well as for codec Opus. So you can, if nothing else, Asterisk 12 will allow video to be passed through it or recorded or whatever else from a WebRTC endpoint.
Thanks.
No problem.
Thank you. Anyone else? Going once, twice, sold. Thank you very much, Matt Jordan.